On math step by step today and every day. It is series of 10 problems work out daily. This is about chapter triangle and this is episode 2. Yesterday I had uploaded episode 1. Thank you for all my viewers having viewed my episode 1 and 10 standard CBSE exam last minute preparation series. Scared about your board exam? Don't get worried. Work out 10 problems with me daily and every day, and you can win over your exam easily. In episode 1, yesterday we had stopped till question number 7 of triangle chapters. So today we are starting with question number 8 of triangle chapter. So the question is using theorem 6.2 as given in the textbook, prove that the line joining the midpoints of any two sides of a triangle is parallel to the third side. So the solution will be, first we will write down what is given. Given is triangle ABC in which D and E are the midpoints of the side AB and AC. Side AB and AC, these are the midpoints. D is the midpoint and E is also midpoint of side AB and AC respectively. DE is the line joining D and E. So to prove whatever they have given in the question is DE should be parallel to BC. So now how to prove it? Let us see the proof. D is the midpoint of AB. It is clearly told in the problem. So AD will be equal to DE. AD will be equal to DB. So that means AD by DB is equal to 1 and we will call it as 1. And then E is the midpoint of the other side, that is AC. Therefore, AE by EC, AE by EC will be equal to 1. AE by EC will be equal to 1, we will call it as 2. So from 1 and 2, AD by DB is equal to AE by EC. Okay, so therefore DE is parallel to BC by converse of PPT. The next question is, they have given that ABCD is a trapezium in which AB is parallel to DC and its diagonals intersect each other at the point O. At the point O. Okay. Show that AO by BO is equal to CO by DO. And this question has repeated in 2014, 16, and 17. So let us write down whatever is given with the diagram, which is easy as per the problem. We can write it down. ABCD is a trapezium. You have to draw a trapezium with AB parallel to DC and its diagonals intersecting at the point O like this. So now to prove, what is that we have to prove? We have to prove that AO by BO is equal to CO by DO. So we'll make a small construction. What is that construction? Through O, draw a line OE parallel to AB and hence parallel to DC. Also because AB is parallel to DC, which is given intersecting AD at E. AD at E. So now proof. In the triangle ADC, OE is parallel to DC, OE is parallel to DC. Okay. And then OA by CO is equal to AE by DE. OA or AO by CO is equal to AE by DE. We will call it as 1 by BPT. In the triangle DBA, that is DBA, this upper triangle, OE is parallel to AB, OE is parallel to AB, like we did in the bottom portion, the same thing in the top portion. OE is parallel to AB, therefore DE by AE is equal to DO by BO by BPT. So taking reciprocals, we have AE by DE is equal to BO by DO. Therefore, BO by DO is equal to AE by D. So this we will call it as 2 and this was 1. So from 1 and 2, AO by CO is equal to BO by DO. So on cross multiplication, AO into DO, AO into DO is equal to BO into CO. Or AO by BO is equal to CO by DO. Let's read this problem and what is given, we will write it down. Given is the diagonals of the quadrilateral ABCD intersect each other at the point O such that OA or AO by BO is equal to CO by DO, or AO into DO is equal to BO into CO. That we will call it as 1. So now what are we supposed to prove? ABCD is a trapezium. So construction through O, draw a line OE parallel to BA. OE parallel to BA. So intersecting at AD, intersecting AD at E. So proof. In triangle DBA, this is DBA, the upper triangle. In triangle DBA, OE is parallel to BA, DO by BO is equal to DE by AB by BPT. So on cross multiplication, we get AE into DO is equal to BO into DE. We will call it as 2. So now dividing equation 1 and 2, we will get AO into DO by AE into DO is equal to BO into CO by BO into D. Therefore, AO by AE is equal to CO by D. So on cross multiplication, AO into DE is equal to AE into CO, or AO by CO is equal to AE by DE. So in triangle ADC, which is triangle ADC, ADC, the left-hand triangle, OE is parallel to CD. OE is parallel to CD. Naturally, that is what is given by converse of BPT, but OE is parallel to BA by construction. Therefore, BA is parallel to CD. Therefore, the given quadrilateral ABCD is a trapezium. In this problem, we are supposed to tell whether the given triangles are similar. So here, what is the similarity? Angle A is equal to angle D. So which is equal to 60 degrees. Angle B is equal to angle Q. Sorry, this is angle P. And this is angle B is equal to angle C, which is 80 degrees. Angle C is equal to angle R, which is equal to 40. So this is angle P, Q, and R. So because of that, triangle ABC is similar to triangle PQR by AAA criterion. Because all the angles are same. So in the second sub question, in triangle ABC and triangle QRP, AB by QR is equal to 2 by 4, which is equal to half. RC by AP is equal to 2.5 by 5, which is once again half. And CA by PQ is equal to 3 by 6, which is also half. Therefore, AB by QR is equal to BC by RP, which is equal to CA by PQ. Therefore, triangle ABC is similar to triangle QRP by SSS criterion. And a triangle ABC is similar to triangle QRP. So the next sub question, no, because triangle MPL and triangle EFD the sides of one triangle are not in the same ratio to the corresponding sides of the other triangle. So, and then in triangle MNL and triangle QPR, ML by QR is equal to MN by QP, which is equal to half. And angle NML is equal to angle PQR, which is equal to 70 degrees. Therefore, triangle MNL is similar to triangle QPR by SA is similarity. SA is similarity because one of the angle we have taken and the other two sides are similar. Next question is no, because both the triangles, one angle is given as 80 degrees, but triangle ABC, only one side containing the angle is given. Therefore, it is no. And then in triangle DEF, angle F is equal to 180 minus 70 plus 80. Therefore, angle F is equal to 180 minus this thing, which results to 30 degrees, because sum of the angles of the triangle is equal to 180. So in triangle PQR, angle P is equal to 180 minus 80 plus 30, because the sum of all the angles of a triangle is equal to 180. So, which on simplification will become 70 degrees. So in triangle DEF and triangle PQR, angle D is equal to angle F, angle E is equal to angle Q, angle F is equal to angle R. Therefore, 70, 80, and 30. Therefore, triangle DEF is similar to triangle PQR by AAA criteria. That is angle criteria. So the problem says that in triangle, this thing which is congruent to triangle OBA, angle BOC is equal to 125 degrees and CDO is equal to 70 degrees. Find DOC, DCO and angle OAB. So what is the solution? DOC and BOC is equal to 180 degrees. DOC and BOC. BOC is equal to 180 degrees because they are linear pairs. They are adjacent to each other. Therefore, DOC plus 125 is equal to 180, and on simplification, you get DOC is equal to 55 degrees, and we will call it as 1. So in triangle DOC plus ODC plus DCO is equal to 180 degrees, because sum of angles of a triangle is equal to 180 degrees. So we know 55 degrees and 70 degrees also we know. Therefore, DCO is equal to 180 degrees if you add all the three. Hence, we can find out DCO as 55 degrees and we will call it as 2. So triangle ODC is congruent to triangle OBA, which is given. Therefore, angle OAB is equal to OCD, which is corresponding angles. Therefore, angle OAB is equal to angle DCO, which is equal to 55 degrees. So we got all the required angles. The next problem, what is given? Diagonal AC and BD of a trapezium ABCD. This is the trapezium ABCD. Diagonals are given and AB is parallel to DC. AB is parallel to DC, intersecting each other at the point O. Okay, to prove that OA by OC is equal to OB by OD. So now how to prove in triangle OAB, OAB, the top one, and OCD, OCD, the bottom one. So alternate interior angles because AB is parallel to AC, AB is parallel to DC and AC. Intersect them Therefore, OAB is equal to OCD. Okay. Next, OBA. OBA is equal to ODC. Why? Alternate interior angles, because AB is parallel to DC and BD intersects them. Then triangle OAB is similar to triangle OCD by AA similarity criterion. Therefore, OA by OC is equal to OB by OD, because corresponding sides of two similar triangles are proportional. So given is in this figure, QR by QS is equal to QT by PR, and angle 1 is equal to angle 2. This is angle 1 and this is angle 2. Angle 1 and angle 2. Okay, now to prove that triangle PQS is similar to TQR, triangle TQR. Or which are those? PQ, yes, this triangle is similar to TQR, the bigger one. So proof. In triangle PQR, PQR, what is happening? Angle 1 is equal to angle 2. So because of that, PR is equal to QP. PR is equal to QP. That is 1, because side opposite to equal angle of a triangle are equal. Now, QR by QS is equal to QT by PR, which is already given. So putting PR is equal to QP from 1, we get QR by QS is equal to QT by QP. So taking reciprocals, QS will come to the top, QR will come to the bottom, QS by QR is equal to the same thing on this side, QP by QT. Now, in this triangle, PQS, in the triangle PQS and triangle TQR, QS by QR, QS by QR is equal to QP by QT. And angle SQP is equal to RQT. Therefore, triangle PQS is similar to triangle TQR. So here the problem says that S and T are the points on the sides PR and QR of triangle PQR, such that angle P is equal to angle RTS. Show that triangle RPQ is similar to RTS. Okay, let us see. Whatever is given, we will just write it down with the diagram. So now what is that we have to prove? We have to prove that triangle RPQ is similar to RTS. RPQ, RPQ is similar to RTS. Okay, so proof. RPQ, triangle RPQ, which is RPQ, RPQ, the bigger triangle, and RTS, RTS, this smaller triangle, angle P, that is RPQ, is equal to RTS, which is given. Therefore, angle QRP is equal to angle SRT, which is the common angle between both. So triangle RPQ is similar to triangle RTS because of AA similarity criterion. So the problem says that in the figure, if triangle ABE and ACD, these are the two triangles, show that triangle ADE is similar to ABC. This question has appeared in 2014 as well as 2016. So write down what is given in the figure. Triangle ABE is congruent to triangle ACD. To prove that triangle ADE is similar to triangle ABE. So what is the proof? This is the given one. So AB is equal to AC by CPCT and AE is equal to AD by CPCT and AD is equal to AE by CPCT. So this is 1, this is 2, and dividing 1 by 2, we get AB by AD is equal to AC by AE, which we call it as 3. So also DAE is equal to BAC, which is the common angle. So from 3 and 4, triangle AD is similar to triangle ABC by SAS criteria. So in this problem, we are given in figure altitude AD and CE of triangle ABC intersect each other at the point P. So to prove that triangle AEP is congruent to triangle CDP and triangle ABD is congruent to triangle CBE, and in the third triangle AEP is congruent to triangle ADB, and in the fourth triangle PDC is congruent to triangle BEC. So what is the proof? In triangle this 2, we will take that angle AEP is equal to angle CDP by uh, by definition of altitude, each is equal to 90 degrees. Then angle EPA is equal to angle DPC because vertically opposite angles. In view of 1 and 2, triangle AEP and triangle CDP, that is AA similarity criteria we can apply, and we can say that both of them are congruent. In the second case, in triangle ABD and triangle CBE, we see that angle ADB is equal to angle CEB, which is equal to 90 degrees. So ABD is equal to CBE, which is the common angle between both the triangles. So from 1 and 2, we can see that triangle ABD is congruent to triangle CBE by AA similarity criteria. And the third one, in triangle AEP and triangle ADB, we see that angle AEP is equal to angle ADP, which is equal to 90 degrees, and angle AEAP is equal to angle DAB, which is the common angle. Therefore, from 1 and 2, we can say that triangle AEP is congruent to triangle ADB by AA similarity criteria. And in the fourth case, in triangle PDC and triangle PEC, angle D, that is PDC, and is equal to angle PEC, we will call it as 1, and each will be equal to 90 degrees. And angle DCP is equal to angle ECB, which is common angle between both. In view of 1 and 2, we can call that triangle PDC is congruent to triangle BEC by AA similarity criteria. Write your comments for clarification of your doubts, which will be promptly answered. Okay, please like, subscribe, and press the bell icon as an encouragement to continue my work. So every day working out 10 problems with me will be definitely helpful for you. Contact for doubts and online classes on gamma for merchandising at gmail.com. And link for the notes, shortly I'll be uploading it, and I'll put the link here so that you can directly get your notes and view my other videos also. The link will be provided.